All right. Once again, you're most welcome to lesson 10 of trigonometry, and we're going to look at the when given the inverse of trig functions, what must you do? This is the last lesson of the compound angle identities. Next will be double angle identities. But please begin by subscribing. That's the only appreciation you can give in to keep this work moving. Okay. Now, number one, we have find part A sine theta if theta equals to sine inverse 4 over 5 plus cos inverse 3 over 4. All right, good. Then what we're going to do is, what we do here, we shall say now in our solution. In our solution, what we're going to do is, all right, now we have theta. Theta equals to a sine inverse of a 4 over 5 plus also a cos inverse of a 3 over 4, like that. Then what you're going to do, we shall say, come and set let. Now you let this, the one is with the inverse, the others we let. You can let this or that. Now here we shall say let. Which letter should we use? Letter A. You may opt for letter A. Let A equal to tan inverse, sorry, it is a sine. It is a sine inverse of a 4 over 5, like that. So this will mean that, now when you have this, it means that it will imply that, when you have sine inverse of this, means that sine A will be equal to a 4 over 5, because you know that at a certain time t, when you have sine A is equal to 4 over 5, you can say A is equal to a sine inverse. So I've just done the reverse. There like that. Same way, letter B will be equal to okay, a cos inverse of 3 over 4. And this will imply that, okay, cos B equals to a 3 over 4. That's where we are. Then we can now say that theta is equal to, now this sine inverse of this, you call it to be A. So I will say A plus the cos inverse of 3 over 4, you call it to be, you let it to be B plus B. Now, after reaching this level, you must now let or introduce in any trig function of your choice. Here, you can introduce in any trig function of your choice. If at all they have not asked, but here they have forced us to use sine theta, meaning that we must use sine theta. So when they have asked for sine theta, you introduce sine on both sides. But if they're not given you this, then when you reach at this level, you can introduce any trig function you want. But they have forced us to use sine, so I will say introduce sine to be now sine theta is equal to a sine of that whole thing, a sine of A plus B. Now a sine of A plus B will give us, a sine of A plus B will now give us, all right, will now give us a sine theta is equal to, okay, expand this. That will be sine A cos B plus, all right, plus cos A sine B plus cos A sine B. Now, to get the value of this, we must substitute in what sine A is. And we have sine A is 4 over 5. Then cos B is 3 over 4. So we have this, we have that. How about cos A? We don't have cos A. How about cos B? We don't have cos B. So we need to get cos B and sine B. And how shall we do that? We shall say now all right, from, say for example, sine A, which is equal to a 4 over 5, you can now draw your triangle like this. This is the opposite, this is the hypo. So the opposite is 5, the hypotenuse is the opposite, the hypotenuse is 5, the opposite is 4. Now you want to get this other balance. And that balance, please, you can use your calculator, just direct. You can get that balance there. Me, I'm just going to use a calculator. Now your balance will be, just you come and say a 5 squared minus a 4 squared. We all know how to go about that. I'm finding this other counterpart. So that will be 25 minus 16. Will give us 9. Square root of 9 is 3. So mean that here we have a 3. Please, you all know how to get that. So now it will be cos. Okay, so here we want cos A. Now you read of cos A from there. Remember this was A. Why A? Is because you have sine A. So cos A is adjacent, which is 3, over hypotenuse, which is 5. Done. Now we also need cos B or sin B. Sin B will be got from this fact that cos B is equal to 3 over 4. So you come and say, I will just do a triangle direct. And from cos B, from this cos B, this is adjacent, this is hypotenuse. So hypotenuse 4, adjacent is 3. We need this other counterpart. And how will you get that? Just be 4 squared over 3 minus 3 squared. 4 squared minus 3 squared, that will be 16. 16 minus 9, that is 7. So here, you're just going to have root 7. There like that, because you must get square root. Or you can go about finding this value of x manually. All now to use the Pythagoras theorem. That's what I've used. Now here, come and read off the cos B. Sorry, is it a cos B? No, sin B. Come and read off the sin B. And now sin B will be what? Sin B, sin is opposite, which is a root 7 over hypo, which is a 4. Like that, then you can substitute here and say sin theta is now equal to sin A is what? Sin A. Sin A is a 4 over 5. 4 over 5 times cos B is a 3 over 4 plus cos A, which cos A, which is 3 over 5 times sin B, which is a root 7 over 4. Can multiply. This dies out with that. So here I'm having, okay, that will be 3 over 5 plus 3 root 7 over 20. You can leave it as that. No problem. Okay. Now next, here we are. Next, here we are. Part B. Find tan theta if theta is equal to this. You all know, with this you have to let. So shall we say in our solution, shall we say let, okay. Here I'll call it a letter you want. You can even call it alpha. Let alpha equal to tan inverse of a 3 over 4. This will imply that tan alpha will be equal to a 3 over 4. Now also, I'll let beta, please you can still call it A and B. Me have chosen to change this to avoid being monotonous. This one is 1 over 7. Okay, tan inverse. That would be the tan beta. Tan beta is equal to a 1 over 7. The next, you now come and refer. Remember, so from theta is equal to a tan inverse of 3 over 4, okay, plus a tan inverse of 1 over 7. Now, what does it mean? Shall I say theta is now equal to, how do you call tan inverse of this? It is alpha plus tan inverse of this is beta. Then from there, after reaching this level, you let this be this one. Where do you have this, you put this. Where you have this, you put this. That's what I've done. The next, they want to find tan theta. So introduce tan theta on both sides. So introducing tan theta on both sides, you have tan theta is equal to a tan of alpha plus beta. Like that. Concluding, this will be, okay, this will be that tan of theta is as good as, okay, expand this, it will be tan alpha plus tan beta over a 1 minus, from the identities, 1 minus tan alpha tan beta equals to, let's substitute. Do we have tan alpha? Tan alpha is 3 over 4 minus tan beta is 1 over 7 over 1 minus a 3 over 4, because tan alpha times a 1 over 7. So now tan of theta will be equal to, please you can use your calculator. So this will be a 3 divided by 21, no 28. A 3 divided by 28. So 1 minus the answer. Good. So I will say brackets. Please you can use your calculator and also get the answer. And confirm with mine, by the way. Okay, tan theta is the same as 17 over 25. Please, the one the value of tan theta, don't again get the inverse. As simple as that. And that's how we handle the inverse. Please, you can also try out this one here. Now, the one cos theta, this one resembles that part A. You can also give it a trial and we see. Don't forget to subscribe. All right, so let's proceed again with the multiple angle identities. And now the multiple angle identities, we are going to start first of all with the first one. The first identity here says sine 2 theta is equal to 2 cos theta sine theta. That's the first identity which you must be knowing. That's the first identity. Now let's see where it comes from. Proof. Now what you must know in trigonometry is that the topic we have covered pushes us to the next. So if I that to derive or to get to see how these formulas come about, we are going to use part of the knowledge of the compound angle identities, where we said sine A plus B is equal to somebody is there. So we have now sine 2 theta is equal to that. Now proof, let's see where it comes from. So shall I say now from okay, sine A plus B, which is equal to sine A cos B plus cos A sine B. That's how we prove it. Now what if we come and say, let A equal to theta, let A be theta, and at the same moment, comma, let B also be what? Theta. What will it imply? It will mean that we shall have a sine of theta plus theta, where you're saying A and B, just put theta, is equal to sine theta cos theta plus a cos of theta, a sine of theta, like that. The next, when you add this plus this, you get sine. When you add this plus this, you get 2 theta is equal to, now sine theta plus cos theta. Cos theta, this one is the same thing. Okay, maybe writing sine theta cos theta plus, you can write this one in form of sine theta cos of theta. Now finally we have that sine 2 theta is as good as, when you add this plus this, you'll get a 2 sine of theta, a cos of theta, and that has been successfully proved like that. Identity number two is cos 2 theta is equal to a cos squared theta minus a sine squared theta. Now, since we're having a cos, we're going to use cos to see how that comes about. So we shall have that cos of A plus B, that's how we get that from, is equal to a cos A cos B minus, when you have a plus, put the minus a sine of A sine B. Simple. Now next, we are finished to let A equal to theta, let B equal to theta. So you now come and say a cos of theta plus theta is now equal to a cos of theta, of course A is theta, cos of theta again minus, because A and B have called them to be theta theta, minus a sine of theta dot again a sine of theta. You realize that conclusively, you realize that this will be, when you add this plus this, that will now give us a cos of 2 theta, which will be equal to, now a cos times cos, you get a cos squared theta minus a sine times sine, you'll get a sine squared theta. And this is yet another proof. Okay, that's yet another proof we have. Simple. Now next, other proofs can be derived from this equation too. Other proofs can be derived from this. We can say now from from sine squared theta plus cos squared theta, which is equal to 1. From the Pythagorean theorem, I told you in trigonometry, as we grow up in very many topics, we tend to use the ones we have covered back then. So from sine squared plus cos squared, which is equal to 1, we shall now say that this implies that from the above, it implies that sine squared theta, when you make sine squared theta the subject to be 1 minus a cos squared theta. That's what it means. Then also, if you make cos squared theta the subject, it means that this one will go the other side, be 1 minus sine squared theta. Now, at first point, let's substitute for this. Let's substitute for this. Now, we shall say from, okay, cos 2 theta, which is equal to a cos squared theta minus, now I want to substitute for sine squared. Where is sine squared? I'm going to put this 1 minus a cos squared theta, like that. And this will now be a cos squared theta minus 1 negative. The second thing will be plus cos squared theta. You see that? Here we're going to have that cos 2 theta is as good as a cos squared plus cos squared will give you a 2 cos squared theta minus 1. That is also another important identity from what we already have. This is also very special and very, very important. Then also from this very cos 2 theta, which is equal to a cos squared theta minus a sine squared theta. Now this time around I want to substitute for cos squared. So this will now be, where the cos squared is, will be 1 minus, because cos squared is same as 1 minus a sine squared theta minus, again, a sine squared theta. So this will now be, okay, that will just be 1 minus a sine squared theta minus, again, a sine squared theta. So what will that be? It will be that cos 2 theta will be the same as 1, this and this, they're all negatives, 1 minus 2, a sine squared theta. Like that. That is also another identity. So there are 3. There are 4 which you must cram. 3. There are actually 2. This one and this one. These other ones can be got from that, and they are all provided in the logbook. Now, why do we call them multiple angle identities? I want you to observe something here. I want to explain using this. If you have here 2, here we write half of what we have there. Say, for example, with this, we can have this. I can as well have a sine of 4 theta, which will be equal to a 2 cos, okay, a 2 sine. When I have here 2, when I have here 4, divide by 2, I put here 2 theta cos 2 theta. These are more like a half angle identities. When I have here 2, this side will put theta theta. Of course, 2 divided by 2 is a 1. So here there is a coefficient of 1 theta. 1 theta. If I have here like a 10, sine 10 theta, here we would have 2 sine 5 theta, cos 5 theta. If I have here sine 100 theta, I would have 2 sine 50 theta. It is half of this is what we write here as the angle coefficient. Take note of that. Or what I can write for you is that recall, when I have, say for example, a sine of 8 theta, for you just to memorize this, a sine of 8 theta is the same as a 2 sine, now divide 8 by 4, by 2, sorry, divide 8 by 2, to be sine 4 theta, a cos 4 theta. That's what we need. This halfway. Same way, even when you're doing with this, cos 2 theta here would have cos squared. In fact, let me be right about that. If I have cos 8 theta, this would be cos squared 4 theta minus sine squared 4 theta. They are half angle. We put half of this for the angle coefficient. See that side. These are the 2 important ones. Make sure they are at your fingertips, because most times they set numbers whereby you need to use them. All right.